Hello guys, my name is Kostis, and in this video I will present you 4 awesome Raspberry Pi projects built for the year 2017, which will make you become more of a power user. You can make these projects on your own, as they are replicable, and you can find the descriptions to make them in the articles shown in the video description below. The first device which I'm going to present you is a tampering device. Now, this tampering device will send you an email event for when someone is accessing your material. For example, let's say that I'm placing this device in the bag. It will get you notified when someone opens your bag, closes your bag, or if someone moves or kicks your bag. So you will get an email event for all of these. So the next device which I'm going to show you is a GPS tracker. Now this GPS tracker has the importance of this tracker is that it collects the coordinates via satellites, and it's very good for tracking moving objects. So it's a tracker which you can use in if you do other experiments or in your car. So it's a really good way to collect these coordinates, or either stream those by 3G, because it also has a 3G, and you can stream those to your computer. So the other importance is that you can collect all those coordinates, and then you can visually generate them in a map shown in your web browser. The third project is a firewall, a Raspberry Pi based firewall. Its code name is PiWall, and its source code is written in Python. Now the importance of this firewall is that it's a hardware man-in-the-middle solution, meaning that someone from the internet cannot switch off your firewall, and you have the total control to write your commands in Python, directly in Python. You can write all your firewall policies and rules in Python, and you can change them. So it makes it more like resilient and powerful together. The last device is the Informer. Now the Informer is an RSS cloud-based solution, meaning that it can collect news feeds from the internet, and then you can see these news feeds both in your, for example, mobile phone, your laptop, or your desktop. And in addition, it offers an ambient solution, because you can see the news feeds on its monitor, and you can place it like side by side with your computer, and like see these news feeds as you work. So now we will proceed in testing these devices in a live test, and we will see how they are working. Now for the first project, let's see the tampering device. Now this here is the tampering device. As we can see on the outside, there is a battery. And when we open the box, we can see a Raspberry Pi here, a Wi-Fi USB adapter, and 2 sensors connected with the GPIO pins, which are an accelerometer and a gyroscope. Now these 2 sensors will inform us whether the object is shaked or moved. And we can also see a cable here which will be connected to the bag's zip heads, so that we may know if the bag is open or closed. So let's put that all together and test it in the bag. So I'm placing it back to its box, and placing the battery. Then I'll just have to power the device by plugging the USB. Right. Now we place the device inside the bag. So this is the bag which I'm going to place the device, and we can see that inside the bag we have attached some sensors on the zip heads, so that when they close and they connect, the device will send that the bug is closed, and vice versa. When they are removed, it will send an email that the bug is open. So we will have to just attach this to the device and place it inside the bag. So I'm taking out the wires and placing them in the device, and now we'll have to place the device inside the bag. The device size is just in the size of a plain book, so it fits well inside the bag. It takes just space of a book. So now we'll close the zip heads and we'll wait for the appropriate email event notification, which will be received through the mobile. So we got the first email saying that the bag was locked, and we'll get some other emails about the device state. So let's try to shake it and move it all together to see how the device will react. So I'm just giving it a bit of a shake here, and we'll get some other emails and which are saying your bag was rated, rotated and slightly moved. So let's try something else now. We will try to open the bag to see if it we get. We got another email, a pull. We'll try to open the zip heads to see if we'll get the email that the bag is open. So I'm going to open the bag and we'll get the final email stating the bag is now open. Oh, we got that. Basically, we didn't get. We got the unlocked, but we didn't get the notification. But so this is the unlocked email here, and states, the bag is unlocked. So now we will move on to the next project. Now let's see the GPS tracker. Here with me I have the GPS tracker, and we're gonna see what's there, and then we will test it in live use in order to collect some coordinates and then show them on a map. So let's see first what's there. On top of the tracker there is a 3G adapter and a GPS antenna. Below the device we can see that there is a battery here which will power up the device. On the inside now we can see that there are two HUDs over the Raspberry Pi. One is the Witty Pi, which is responsible to automatically open and close the Pi if it's needed, and the other for GPS tracker. And there is also an antenna here, a USB extender here, and a power cable here. So I have extended the power and I can click it from outside the box. Now I'm gonna place this device in a bag in order for me to take a walk with it and collect some GPS coordinates. So here I have my bag. I will just have to extend the 3G a bit with this cable. So I will place this cable inside the pipe, like so. So I'm placing this cable like this. On its top I will insert the 3G adapter and power up the device. now we'll insert the device inside the bag, like this, and place the antennas on top of the bag in order for them to have a better signal actually. So just placing the wires together and placing it, so the bag is set. So now we'll use this bag to try to collect some GPS coordinates. So guys, I have returned from my walk and now we'll see how the GPS tracker is able to collect all the data points and generate a visual map. So here I have the GPS tracker, only this time the 3G adapter is being replaced with a Wi-Fi USB adapter. In addition, we can see that the battery is being removed and the device has now power via power adapter. So we have replaced the 3G with a Wi-Fi in order for the device to be able to be accessed via the local area network, and I'm going to use the SSH protocol in order to access the device. So I will open PuTTY here and I will give the device's IP address, and this will allow me to connect to the device. So I'm just giving the password. Now I'm inside the device and I will just have to go to the projects folder and do Python generate gmap. So all the collected data points are being stored in a map. So now the next thing to do is download this map. In order to do that, I will open FileZilla and use SFTP, basically SSH, but to download files. So I'm giving the same credentials as before, and as soon as I'm connected with the device, I can download the map in the desktop and view the map. So this is the map. I started and stopped from the same point in my walk, and we can see this is the route I followed. So we can see that the points are like in some spaces there is some inconsistency, but the points are kind of fluid, you know, and they can track the moving object pretty well. So this was the GPS tracker. So now guys, we will move on to the third project, the PiWall, and we will connect the PiWall to my home network. So now here I have a typical network switch. This cable comes from the router. It's basically the internet, although these two cables are the internal hosts. So now I'm going to interfere the firewall between this one and these two. So I'm taking the firewall, the PiWall, and placing it like this, taking the internet cable and another one, a red cable, and I'm forwarding the network traffic through the firewall. So first it will hit the firewall and then it will move to the internal hosts, and vice versa. So now the firewall is set, but if I need to make it a network host by itself, I need to place a third wire. The third wire will make sure that the firewall will be accessed by the internal host, and so that its policies may be changed. Now the last wire is the power cable. As soon as I place the power cable, we have a ready PiWall to go, and it may start working in a moment. So now it works. We have to wait for a while, and then we are ready to go. Okay, now we have connected the PiWall and we are going to test it through an internal host from our network. So I'm going to first of all see the user's experience, and in order to do that we'll have to open a web browser and see how the internet will react. So, you know, a typical web browser, and I'm going to YouTube,
and I can see, you know, the YouTube loads perfectly fine, and I can, you know, play something. Everything is okay, but let's right now try to stop the firewall, so that we can actually understand that there is a man in the middle. So that's the simplest experiment to do. So I'm going to stop the internet traffic to show that it's being forwarded through the PiWall. So I'm going to use PuTTY, and I'm going to give the PiWall's IP address and log into it. So I'm going to use the credential. I'm waiting for a password prompt, and as soon as I get it, we'll proceed. So now we are inside the PiWall, and I'm gonna do just you know, sudo kill all python3. That will terminate the firewall's logic. So let's see what happens here. Is that, you know, did so, and let's see now. You know, the buffer stopped. No video now, and that's let's see another one, for example here, and that's clearly a proof that, you know, that there is a man in the middle. Someone is routing the traffic. So there is no internet anymore. So right now let's try to do something else. We'll try to use the first script, which is the learning script. So I'm gonna do cd to the PiWall's directory, and I'm gonna use first of all, I'm gonna show you how the firewall is doing that, which is doing the forwarding, being man in the middle. So I'm gonna do sudo just nano PiWall learn. This is the simplest script and allows someone to learn how to use the PiWall. So we can see that there are two interfaces and two functions here, and there is a while in each function, and it collects a frame from one interface and sends to another, and vice versa. So that's a man in the middle, and it's defined in software. So when I try to run this script, I'm gonna do sudo because I'm accessing the interfaces, so I have to be sudo python3 PiWall learn, and as soon as I do that, we'll go back. You know, we have internet again, and the buffer loads normally. You know, it's clearly someone doing a refresh. You know, everything is fine, but in this example there is no firewall logic, so it's plain man in the middle, but there is no firewall. So I'm just gonna kill this, and we're gonna see the real firewall, which is nano PiWall, and we're gonna study it. So here is the real firewall, and as you can see, I have defined some policies here. We can do all sorts of things, and you can write on my own script if you want to, and change what I already did there. I have a missing part with the DNS, so you can track your DNS requests and responses here. There are some codes for the ARP and DHCP, and you can change all of those stuff. And at the end, there is a simple script, open to interface, and do the same thing. So let's try this one, and we can see some live input, some live output actually. So I'm doing sudo python3 PiWall.py. So here you can see there is verbose information about our firewall in a live use, and you know, it works normally as before, and it's, you know, it's really good. You know, the traffic is being forwarded back and forth the firewall, and you can do all sorts of stuff, even change your traffic as long as it lives. For example, if you provide a phone number, your firewall may automatically change this number, revoke it, and you won't have to be compromised on your personal data. So this is PiWall, and we will move now to the next project.
So now, moving on to the last project, we will see the Informer. So now this is the Informer, and I will just have to power it up. As soon as the Informer loads, we will have a web interface with RSS, and we will be able to access it from all hosts inside our network. So now we'll just have to access the web page. And as soon as it loads, we'll have to give in our credentials and then log in, and we'll have the newsfeed. So we'll just have to type Finally, this is the newsfeed, and as mentioned, you can access it from any host which can have a web browser. So guys, these were the 4 projects which I implemented for this year, 2017. I hope you liked them, and you can click in a project to see it again. And you can also view the description below the video to see the articles in order for you to make those into your own environment. So, thank you for watching.